Alright, this is going to be my intro to pointers video. I'm going to start off by reviewing on what a variable is. When we create a variable, such as int num here, and let's say we give it a value, the computer is going to take that variable and assign it a place in the memory. And the amount of space that is allocated for it is based on whatever data type it is. So we have an integer here. 4 bytes are going to be allocated for this variable that we refer to as num, but the computer will always just be looking at the address num is stored at. And then it will have a value, which in this case is 5. So if we were to look at that, we have our variable here. We call it num. It has an address. I put 100 here, but that address will actually be much larger. It could be anything. The operating system decides where the variable is going to be stored. But let's just say it's at address 100, and then it has a value, and we said that was a value of 5. So that's what it looks like right now. A pointer is a variable that points to some other variable. All pointers effectively store the address of some other variable or object or function. So if I wanted to make a pointer that points to our variable num here, we start by saying this is the data type. It is an integer pointer or int pointer. So you can almost think of it like that, as if the asterisk is part of the data type. And then we set it equal to some variable we want to point at. In this case, it's going to be num, so we would say the address of num. And so you want to remember that a pointer always stores an address. Just make a note there. Pointers always store an address. That's not entirely true because they can be set to null, but the value inside of them will always be an address if it's not null. And now we have a pointer here called PTR, and PTR is pointing at num. And so what that looks like, if I go back to my spreadsheet, we'll have the variable PTR. It is a variable within itself. It also has an address, and since num is occupying 4 bytes, PTR will probably show up at 104. Pointers are integers in themselves, but that's not too important right now. So it'll have an address of its own, and then it will have a value. And we said that value was the address of num, which in this case is 100. And so this is what our memory looks like. We have num, our first variable. It has an address that we don't care about, and it has a value. And then PTR also has an address that is not important, but its value is the address of num. So this pointer points at this variable. If you're going to use a pointer, or if you want to change a variable or read a variable using the pointer rather than using the name of the variable itself, you can do that using the dereference operator. And that is also the asterisk. So we could say cout num, like that. That's what we are accustomed to. But we could also use our pointer. We could say cout PTR. Now if we cout PTR, we'll only get the address of num. If we want to see what num is using PTR, that's where the dereference operator comes in. And that is the asterisk. And this, when you use it like this, we refer to it as a dereference operator. Up here it's different. This just says we are creating a pointer, not an integer. Down here it's saying, don't give me the address of num, give me the value at that address. So these two statements do the exact same thing. and we can run that and test that out. And you can see here I get 5 in both cases. If I do not dereference my pointer, I will get the address of num, which will be something in hex by default. So you can see that there. I'm going to make this font a little bit. I'm going to try to make the font a little bit bigger. There we go. So this is the address of num and the value of our pointer, and you'll seldom need that, but if you want to work with the pointer instead of with the variable, you dereference it. And that's for both reading and writing. We can change num using the pointer by dereferencing the pointer. We can say dereference PTR equals 10, and that will change num, and so when we see out num down here, we will see that change take effect. So there you go. And that is called dereferencing a pointer. It says give me what's at that address. If you wanted to assign null to a pointer, that's also valid. So in C you would typically see something like PTR equals null, which is a macro for just 0, and then you could also say that PTR equals null pointer, and this is not 0. This is just to say that that pointer is pointing at absolutely nothing right now. Both of these are used. A lot of times you will see in books and things that if you create a pointer, you should always initialize it to null, especially if it is a member pointer. If you have one in a class, you would say, int PTR, let's say PTR2 equals null pointer. And that can save you from some pretty nasty bugs if you're not careful, but not overly important right now. You can initialize it to a variable if you want to. So that covers the very basics of what a pointer is. You want to just always keep in mind that they are an address. And as simple as that is, the pointers allow you to do some incredible things in C++. So they open up a very large can of worms. If you can access the address of something, you can do some pretty awesome things. And so it's what gives C++ a lot of its power and also a lot of its problems if programmers are not careful using them. So a very two-edged sword. In the next video, we'll move on to passing pointers, returning pointers, member pointers, arrays of pointers, and then a whole lot more other stuff. In fact, there are entire books just written on pointers. But that's the bare basics, and we'll continue on from there.